All right, thanks everybody for joining today. We're continuing in a set of talks about perfSONAR and some of the recent enhancements and projects that the various partners have been working on. And Sowmya has been kind enough to give us some of her time today to talk about the improvements to the Lookup service that have been made recently and with a couple of new releases coming up. So I will turn it over to you, Sowmya.
Thank you, Jason. Hi, everyone. I'm Sowmya Balasubramanian. I'm a software engineer at ESnet, and I've been associated with the perfSONAR project since 2010, mainly working on the lookup service side of things. So today I'm going to be talking about one of the pretty big milestone that we reached sometime last year, which was to move to Elasticsearch, and then talk about what is in store now that we have this Elasticsearch based backend. So I'm pretty much, I think pretty much everybody here knows who ESnet is, but for those who don't know, we are DOE's high performance network, and we enable big data science by providing connectivity to all the various Department of Energy labs, various experiment sites, and supercomputers. And I'm also assuming that you're familiar with perfSONAR, which is basically a set of tools that allow you to make run tests and measure the network. And so in that, specifically, if you've used the perfSONAR tool, especially to find a host and then run tests. So typically to a host that is not in your network or in your organization, and you've used a web interface like this, where you went in and searched using some keywords to retrieve some hosts that you were interested in running tests to, then you've definitely used the lookup service. So what is the perfSONAR lookup service? So you can think of it as the, kind of like the directory for all the various perfSONAR toolkit hosts. And there is a front end to it, which is what I've shown here, and that runs on stats.es.net/services directory. And if you look at the perfSONAR software architecture side of things, a typical toolkit has a combination of a bunch of different tools that you can use to run tests. And then there is a scheduling component, and then some kind of a archiver, which will store the tests. And then there's a few visualization tools. And if you're using a central management, then you have some something like a PS config, and maybe UI related to that to configure the various tests. And typically a lookup service, and then there's also a lookup service registration daemon that is running in each of these toolkits. And that is what is responsible for collecting all the host-related information, some metadata, and registering that with the lookup service. So the lookup service itself does not run on any of the toolkit hosts. So it is a separate service that is hosted by the perfSONAR community. And all the various toolkits that want themselves to be discovered just go and register themselves to the lookup service. And then the UI that I showed in the earlier slide, the LS services directory, that basically goes and retrieves all the information that is in the lookup service and displays that in a couple of different formats. So you have a search interface, as well as you can see the map and see where all these different toolkit hosts are located. So coming to the lookup service itself, so if you look at the lookup service, it's actually a simple web service, and it has a REST JSON API in the front end and a database in the back end. So right now the REST JSON API has been written in Java, and the database has been, now it is Elasticsearch. And this whole lookup service basically runs in a virtual machine in Google Cloud, and we have monitoring and alerting and all that set up. So we just leverage the Google Cloud tools to basically monitor the health of the lookup service, notify in our perfSONAR Slack channel, as well as send us email alerts if the lookup service is down. So before we go into the various features of the lookup service, I thought I'd just take a quick moment to kind of set the stage as to like the overall journey the lookup service has taken, especially this particular version. So this particular version, when I say this particular version, it's the REST-JSON based lookup service. So this was released sometime in 2013. And at that time, it had MongoDB as its backend. So MongoDB is another key value store. And it's also a very pretty good database. And at that time, we didn't have Elasticsearch was not that popular, and so we went with MongoDB as the key value store. And at that time, the deployment model was also a little bit different in the sense we had quite a few instances deployed across the world, and that was because we just went with a model that was similar to its predecessor. And then we ran that for a few years. There were quite a few learnings over that time. And as people started using the lookup service, there were a few more things that people desired. And so sometime around in 2018, so what we did was we went and did a requirements refresh, because it had been quite a while since the old requirements had been collected. And we also wanted to incorporate some of those learnings. And so in 2018, we did that requirement refresh. And then based on that, we consolidated the deployment that was spread across the quite a few instances. And we consolidated that into a single instance and moved it to Google Cloud. And then since then, it's been running pretty, it has been pretty stable. And so now we started to focus on some of the other aspects that we learned in the requirements refresh that we did. And so one of the big thing was last year. So we basically released a lookup service with Elasticsearch backend. So we replaced the MongoDB, and I'll go over the reasons for doing that. And then now that we have this Elasticsearch backend and it's been running stable for a while, we are now looking into some aspects of doing some data validation, improving the APIs further, and so on. So before going into the features and stuff, a quick look at like what we learned in 2018 when we did that LS requirements refresh. So the full link, like if you're interested, there's like quite a number of things we have listed in this document here. But basically, whatever requirements we gathered could be categorized into these four main areas. So one is around the data and APIs. And there were things like improve the query API so that we could add more search capabilities. And another one was to improve the query response times. And then also think about efficient APIs, and then do some data validation. So under monitoring and alerting, we wanted to get some performance monitoring to improve stability, so that if there is some issue, so there should be some constant health check that should be running. And if there is an issue, alert the perfSONAR community, the developer community about that, so that we can intervene and fix the issue and reduce the downtime. And then the third area, so this was not exactly a requirement that was given to us from the community, but this is something we as the developer community wanted to provide, because if you look at the lookup service, it is pretty open. And that's actually a big plus for the lookup service, in the sense that since it is open, it is easy for new folks, new hosts to quickly join the ecosystem. But at the same time, if somebody wants to verify the authenticity of the records that are there in the lookup service, currently there is no, or there was no particular way they could do that. And so we wanted to introduce security, or at least provide some basic authentication for the records. And then the fourth area is architecture and deployment. And this was something, especially when we started to investigate the cloud space, one thing we were clear was that even if we go to the cloud, we should still look at the ease of deployment on-prem as well. Like if at some point, so basically, we should not be cloud dependent. So if at some point, Google Cloud becomes ridiculously expensive, then it should be easy to move it to on-prem and deploy and do the monitoring and all that. So not rely too much on Google specific products. And also the second thing we've been doing since 2013 is the support for private lookup service. So if an organization wants to deploy these perfSONAR toolkits and have a separate lookup service, not registered to the publicly available one, but instead deploy their own and register their toolkits into to that particular private LS, we wanted to ensure that we continue to do that. And of course, things like redundancy and availability was also something we wanted from the lookup service. So since this refresh, there have been few things we have been adding to the lookup service. So the first thing, sometime I think in late 2018 or maybe 2019, we added the support for security. So right now, the current lookup service and the tool LS registration daemon supports the signing of records. It is not enabled by default, but if you wanted to do that, so there is this particular field in the LS registration daemon, the add signature field. You just have to flip that to 1 and then give it a key. And if you wanted to verify the records, then you just needed to specify the path for the certificate that you wanted to use for verifying. And so right now, the assumption is the public key would be either made available out of band, or if you want, that can be another record in the lookup service itself. So this is something that's actually, it is already in deployment today. And if you wanted to start using it, this is something you can start using from today itself. Then the second thing we did was we focused on the improving the APIs category. And one of the first things we did was we tackled bulk renewals. So if you look at the lookup service, there's each toolkit as it registers, it does not just register one record, it actually does, it collects the host information, there is the interface related information, and then admin, as well as some of the metadata. So it collects all that, and it actually sends them as individual records to the lookup service. And so this means that there's like extra exchange between the client and the lookup service server. And we wanted to cut down this exchange. So what we did was we have added the support for bulk renewals. So what you can do is once you've finished registering, the LS registration daemon, it stores the record URIs for the various records that it has registered, because that's what it uses for renewing them. And so now it can just put them all in one message and send them to the lookup service. And the lookup service sends back a response. It's either all of them have succeeded, but if all of them have not succeeded in renewing, then it sends the partial failure list, which of the records failed and what reason it failed. Most of the times it's mainly because of because the lease has expired on the record. And after that, the next thing we focused on was to improve the query API itself. And so if you look at the lookup service API, so it has a very limited query API. you can just do some searches based on some key values, and also there's like very limited wildcard support, more like a prefix search kind of a thing. So we wanted to provide the capability, now that we have this data and everybody's registering so much of information. If you want to search, unless you have that API, basically there's no use of all that information sitting in the lookup service. And so there are two ways we can do this. One is we re-implement all that capability, whichever capability we want, in the lookup service API itself, and do that as part of releases. Or we could leverage an existing solution that already had the REST JSON APIs. And so we decided to do the latter. And so that's why we went in. And plus the other factor is the lookup service has been written in such a way that there is actually decoupling between the database layer and the front-end API. So we could easily take that out, just replace, and we just had to write basically, we had to make basically replace just one class that would do the translation between the front end to the database. And so currently we are supporting both. So if you look at the lookup service that has been deployed now, we have the existing set of APIs that it usually supports, which is the registration, renewal, delete, using the put, post, get, delete, and all that. But at the same time, we have also exposed the Elasticsearch query API through a proxy. So basically, if you go to this URL, which is basically /lookup_search, and if you send it a get or a post request with the search parameters, you can actually leverage the Elasticsearch API directly. So what can you do with this new capability? So we can do the existing set of like the simple key value based searches, definitely. But then the Elasticsearch API actually provides these filter and match queries. So what you can do is, if you provide a filter, so let's say you're interested in just the host names. So then you can provide a filter of type host, and this actually cuts down the search space of the Elasticsearch when it's searching for the data. And then you can provide a match query, and you can give it pretty much any of the different key values that we have. And in addition, so right now here in this example, I've used a must match query, but you can actually give it, you can have an absolute match, you can have relative thing. So there's like a whole list of features that the Elasticsearch APIs provide, and you can just leverage all that. And then the second thing that you can do now is you can retrieve only what is needed. And by that, I mean that you don't have to get back the entire JSON records if you don't want. And this will actually help, especially if you're having a very interactive, like you're trying to build a very interactive UI and you want to quickly query for something and just display the short results. You can actually leverage this particular feature. So for example, here, I'm actually looking for hosts that belong to ES.NET. But what I'm saying is I don't want the entire record. So for some reason, if you're just displaying the OS name, so then I can just say, just give me the host name and then just the host OS name. And what happens is here, if you look at the results, you can see that it is only giving you back just those two fields instead of sending back the entire response. And in addition, of course, there is like few other things in the Elasticsearch where you can actually associate a score. And this is especially useful if you're using text queries, which means that you can use the score to say, whether a particular record is a good match for the kind of search that you're doing. Some of the other things that you can leverage now is if you're trying to get large set of records. Right now, you just get an entire dump from the current LS. And that takes like few seconds. But now instead, what you can do is you can leverage pagination, which is provided by Elasticsearch. And not just that, if you're trying to display like the top end results or maybe the bottom end results, then you can actually leverage the sorting feature of the Elasticsearch. And there's like few others that you can do. So there's like a whole list, like you can pretty much leverage the query DSL capabilities of the Elasticsearch query. So those are like some things that you can actually try today using the URL that I showed on the screen. And so now that we have this Elasticsearch and it has been running, so we deployed that sometime in the late 2020, and it has been running, it has been stable for all these months. So now we have started to look at some of the other things that we can do. And one of the things we want to do is start looking at data validation. So the idea is we want to improve the quality of data that is stored in the lookup service. And if we want to do that, the lookup service needs to understand the type of data. So if you look at the data currently that is stored in the lookup service, it is all key value store, and it's the values are simple strings. And so we need a little bit more. From the lookup service server side, it needs a little bit more understanding of the type of data that is there and all that. And so the first thing we thought about was we considered schemas. We thought we could define some schemas for established key value pairs. And so we went down that effort a little bit. We tried that. This was about probably, it's a slightly older set of work. So what we did was we defined the schema for person, host, interface, service, and PS metadata. Basically, all the records that are in existence today in the lookup service. And by defining the schema, this would enable like the type and format checks. Like for example, for latitude and longitude, since it's we know it's a float between a specific range, we can actually do that check. For interface capacity, we can check whether it's integer. We can check for email formats, host names, and all that. So, so this work is actually, we did this and it's actually in the GitHub repository. So if you're interested, I do have the link here and you can go over some of like the schema ideas that we had. But then there is like few challenges with the schemas. So one is we definitely require server-side validation, which means we now need to develop code and push that into production. And once we push that into production, we need to ensure that there's also this client-side dependency that all the toolkits must have the latest version in order for us to make progress in the data validation part and all that. So, so we wanted a solution that would not have these kind of dependencies, so that we can actually start looking at some of we can focus more on the validation, the normalization side of things. And so we have now come up with another approach, and that is to leverage Logstash. So since Logstash is part of that overall ELK stack, which is Elasticsearch, Logstash, and Kibana, and these products work pretty well with each other. And so the idea is we build Logstash pipelines, and what would happen is these Logstash pipelines would actually take the data that is in the lookup service, and they would do the normalization and any checks we want to do, any conversions we want to do, and then write that to a different index. And once we do that, we have this potential to do some transforms, some rollups, and all that. And so when we go down this approach, the advantage is we don't have to touch the production LS. All we are doing is we'll be issuing a search, just a simple search command there. So since this is a little bit open-ended and there can be, the scope can grow out of bounds, we set some initial goals. So the first goal is we create a single pipeline that reads the data from the lookup service periodically, normalizes it, and writes this normalized data to a different Elastic index. And what we wanted to do was, once we have this, so when I say normalize, we would just select like certain fields and a subset of the overall thing we want to do. So we wanted to define that, and then once this is done, we want to make it available for users to experiment. And once users experimented and provide us with feedback as to like, what they find useful and what they care about, then we can take those and make sure that we develop that into a fully baked product. And then the other thing we want to start doing is start maintaining periodic snapshots of the lookup service data. Now, when we start collecting that periodic snapshots, then there's a lot more interesting things you can do with that. You can look at history, or you can actually start doing some rollups, some transforms, and all that. So it'll start giving us more interesting. We can start asking more interesting questions. So what would the architecture look like? So basically, the idea is we would have, this is the existing production lookup service. There would be a cron job or something that would take and then like there would be a logstash pipeline that would run and normalize the data and then write it to the Elasticsearch. And even though this is actually shown as a separate instance, in fact, these two can share the same backend LS instance, because we'll be writing to different index anyways. So the work we are doing, so actually, Jayant actually did some work in this area, especially for the validation and analysis. They actually did some work a few years ago. And at that time, they actually used a Splunk cluster. And they've actually documented all the findings. And they shared it with the perfSONAR developer community. So we have actually taken these findings, and we are factoring that when we build these logstash pipelines. So what is the current state of this work? So right now, it is still in the proof of concept stage. So right now, we do have a basic logstash pipeline, and I was able to get it to read the Elasticsearch data and normalize a few fields and write it to a different index. So we know that this particular thing, we have something that works in its most basic form. And so what are the next steps? Now we need to complete the logstash pipeline. And by complete, I mean that we define the various fields that we want to normalize in this initial round. And then the other big goal is to make this normalized data. We want to make it available to the users in the coming months. And so basically, this is kind of like what we have in store for the lookup service. And basically, so that it's been a pretty interesting time for the lookup service. Now that we have a very stable service that's running in Google Cloud, we have some monitoring, everything in place. We have now started to focus on providing more value. So if you have some ideas as to what would be useful, what kind of queries would be useful, and all that, I'll be happy to take that feedback. And as I work through this normalizing pipeline, I'll take that back to the developer community. We can try to incorporate those things in the in this particular feature. And yeah, and then once we have these interesting search queries and all that, then the next focus would be on the visualization side of things. How do we, now that all these capabilities are there, how do we make it something that users can easily access? So that, in summary, is like what we have been doing in Lookup Service and what is in store in the Lookup Service. And on that note, I'm happy to take any questions.
All right. Well, thank you so much, Sowmya. Certainly, it's come a long way And we didn't even mention the pre history of the lookup service, where it was written by myself and Aaron Brown back in 2006 over a weekend, and it used XML and was awfully inefficient. So glad that it's finally operating at a high level here. I had a couple of questions while we wait for other people to chime in here. First thing I'm just curious about is, now that it's moving to a more efficient platform here, how long will it be until we can phase out sort of the older generations? I know that sort of some of the toolkit instances that don't get updated and some of the legacy services will probably always have to hit that old one. How long do you envision keeping the old one up while it's transitioned over to the new thing?
So by old one, which one do you mean? Like the MongoDB version? Or
Yeah, the MongoDB one, or
so
yeah.
I think so basically from the toolkit perspective, I think most of the toolkits. I mean, in fact, pretty much all the toolkits right now can start registering, in the sense there is nothing preventing them except for the update to that URL. So basically, I would say at this point we have actually stopped the older one, and this has been a seamless thing for pretty much, I would say, pretty much all the toolkit hosts. So at this point, even if they've not realized, they might have already been hitting the new LS, actually. Because what happens is we have updates. So there is this active hosts .json file, which is a bootstrap file. And so all the toolkits, which spoke either to the MongoDB or the Elastic one, so in order to bootstrap, they would actually go to that particular file, which is running on PS West, and use whatever URL is in there. And since that URL points to the new lookup service, I would say pretty much all of them have transitioned to this new one. Does that answer your question?
Second one, yeah, that clears it up for me. I was sort of missing that piece of it. I forgot that we sort of had that transparent piece in there. So my second question is, we typically, maybe we don't get them anymore, but there used to always be questions about people who wanted to run their own instance of the lookup service, maybe because they had a private network and they didn't want to expose any of their perfSONAR nodes to the greater world. In this sort of new paradigm, is that still going to be possible, or is the lookup service mainly meant to be a public facing thing that can't be deployed within a private instance?
Oh, no. So we are still, so I think that's one thing I mentioned as part of the, let me see. So when I was discussing the various requirements, I did mention that this is like one thing that we will continue to support. And it's actually still true even with the Elasticsearch.
Okay.
So it is still, so the only thing that changes in the case of Elastic is you are, instead of installing the MongoDB RPM, the users will install the Elasticsearch RPM.
Okay. Well, good. So I'll put out the call here again. If people have any questions, please certainly type them into the chat room. At the end of your talk there, you said, what sort of queries would people want to run against this? The thing that I've always been interested in, and I still do it on my local machine here, is I basically run a script that dumps the entire LS sort of on a nightly basis and just kind of consolidates that on a domain basis. And it's mainly useful for me so that I can, if somebody comes in and says, hey, I'm having a problem getting to this network, I can quickly look up and get what I wanted to do. Has there been any thoughts about running more or less regular reports that could be sent to the perfSONAR user list, maybe to warn people of needing to upgrade after a security incident, or any other sort of reports? Or is it or what you're thinking, and people are just going to sort of do things on their own?
So basically, so one of the things we can, so once we have some of these search capabilities in there, in fact, we can run those kind of reports. And in fact, I believe there is, so right now it's not being sent anywhere, but we do have a script for running those kind of reports, even with the current LS. But it's not, currently it's not being sent anywhere. But I see your point. So we could, the first thing we can do there, and I'll actually take a note of that just a second. So we can actually expose those reports right now as is, like, it'll be just an email digest kind of a thing, but we can send that to the perfSONAR, either the developer list or the user list, whichever we want. We can actually do that right now. The second thing would be to actually, once we run those reports, make it available in a more visually pleasing way, like maybe have some kind of a dashboard or something where people can go in and actually look at all this information. So that is something we have entertained, but that's, again, like once we have all this infrastructure, then we can build. So I didn't go into too much detail there because it's a little too early now, but some ideas we have entertained is probably building some kind of like a dashboard where you can go there. It'll quickly show you, okay, so these are like these many hosts are running this version of CentOS, or these are running this version of Debian Ubuntu, those kind of stats.
Yeah, actually, that was what I was going to sort of have as my follow-up question. Knowing what the population of certain OSs would certainly be valuable to follow on what Antoine was talking about after the PS EU meeting recently. Mm-hmm. Also, sort of coverage by 10 gig and 1 gig and 40 gig hosts. So yeah, I guess there is a lot of great analytics that would come out of that. Mm-hmm. So Chris entered in a question here. Let me read it. One of the things we've been doing is dumping the DB and using that to do geographical searches. Basically, what perfSONAR nodes exist within an X mile radius of any given latitude and longitude. Having some sort of geographic-based query built into the API would be good for their use case.
So yes, so and that is actually possible through the Elasticsearch API. So that's where but it's what is still missing is the conversion or the validation piece, because what's happening is the latitude longitude are right now stored as strings because of the way it was originally designed. And that's where the Logstash pipeline is going to help us. And one of the things we will be doing is converting the latitude, longitude into a float-based number, and then you can leverage the Elasticsearch API to actually run those kind of geographical queries. Like you can say, give me hosts that are in this X mile radius kind of a thing.
Yeah, it sounds like a good idea. I mean, also the holy grail would also be having topological information in there. I know that one's a little bit harder of a nut to crack, but knowing how far away things are from domains and things like that.
Yes, that has always come up. We haven't, I think that would be something we can definitely entertain. Like, it's come up a few times, even in the developer meetings and stuff, but we haven't figured out a good way to map those yet in the lookup service. But I definitely see the point there.
Oh yeah, certainly not. I mean, that's been a discussion for the 17 years I've been involved in perfSONAR. So one of these days we'll get that one solved. All right, well, I don't see any more questions, so I'll put out one last call here. If anybody does have anything, please enter it in. And thank you again, Sowmya, for going through this. We'll make sure that we get your slides posted along with the video.
Mm-hmm. Yeah, thank you.
And let me look and see what our schedule here is. So next week we do not have a talk, and then we're off for 2 weeks. And then we're going to have another talk in a couple of weeks, and it is going to be Claudio and Fabio talking about the time map project from Jayant, which is a latency and jitter measurement project for the Jayant backbone. So that'll be on June 4th. So we'll have a 2-week break, everybody, and hope everybody has a good holiday weekend if you're in the States, and we'll talk to everybody soon. Thank you so much.
Thank you.